We're going to talk about power functions and transformations. So we're going to start by defining a power function. A power function is defined by ax to the n. So this could be x to the second, x to the third, x to the fourth, x to the fifth. We've already done quadratics. We've entered into cubics, and we can even get powers higher than 3. The end behavior of a graph as x approaches infinity and as x approaches negative infinity. So we take our cubic function. Remember, the parent function looked kind of like that. So as x approaches negative infinity, that's the left side of the graph. What is the y value doing? Well, on the left side of the graph, the y value is going down. It's approaching negative infinity. As x approaches positive infinity, that's the right side of the graph. F of x is approaching, well, this side's going up. So it's approaching positive infinity. That's for our x to the third, our cubic graph. The fourth power is called a quartic graph. If you see that anywhere, think about a quarter, which would be 4. Same thing for the right side and the left side. X to the fourth looks a lot like your quadratic graph. It's a parabola. It might be a little bit flatter on the bottom. As x approaches negative infinity, that's the left side. What is the y value doing? It's getting bigger. It's approaching infinity. As x approaches positive infinity, that's the right side. Y is approaching positive infinity. So that's going to hold true for our x to the fourth power graphs. So we're going to describe the end behavior for any polynomial function based on these two. An odd degree, maybe it's x to the third, x to the fifth, x to the seventh, any odd degree function. If a is greater than 0, then we're looking at a graph that's down and then up. So in mathematical language, we're going to say as x approaches negative infinity, f of x approaches negative infinity. The left side's going down. As x approaches positive infinity, f of x approaches positive infinity. The right side is going up. Now, if a is less than 0, remember that was a reflection over the y-axis, over the x-axis, sorry. So if I reflect, now the left side's going up and the right side's going down. So we'll take our mathematical language. As x approaches negative infinity, f of x is going up to positive infinity. As x approaches infinity, f of x, because we reflected it, is now going down. That is for every odd degree power function. For even degree functions, x to the second, x to the fourth, to the sixth, to the eighth, any even degree. And by degree, we're talking about the largest exponent in the expression. That'll be our degree. So if a is greater than 0, we're going up, up. So we will say as x is approaching negative infinity, f of x is approaching infinity. It's going up on the left side. As x approaches positive infinity, f of x is approaching infinity because it's still going up. Now, if we reflect this over the x-axis, now a is less than 0, so it's a negative value. We're pointing down. So as x is approaching negative infinity on the left side of the graph, we're going towards negative infinity. As x approaches positive infinity on the right side of the graph, f of x is approaching negative infinity. So notice my even degree powers are up, up, or down, down. They're going the same direction. My odd degree powers are opposites. It's down, up, or it's up, then down. So let's take a look at some examples and see how to apply this information. State whether the function is even or odd degree, and if the a value is positive or negative. So notice these are both going down, down, down. So I know that this is an even degree. and the a value is negative because they're both pointing down. Look at letter B. Notice on letter B, I've got down and then up. So this must be an odd degree because they're going different directions. And in our odd degrees, down and then up means the a value must have been a positive. And the same thing happens with letter C. It's down and then up. Since they're going different directions, that's an odd degree. And the a value must be positive. Let's take a look at how that works with some equations. So when we're looking at equations, we want to pick the largest exponent. That's going to be our degree. So on letter A, 2x to the third is my largest exponent. It's a positive odd. So to determine the end behavior, I'm just going to write one sentence over here and we'll just repeat it. As x approaches negative infinity and as x approaches positive infinity. So for letter A, as x approaches negative infinity, f of x, because it's positive and it's odd, is approaching negative infinity. Positive odd, as x approaches infinity, f of x approaches infinity. Let's go to letter B. Notice the largest exponent is a 2. So this one is positive, the 6 is positive, and it's even. So positive even, we said both ends were going up. So as x approaches negative infinity, f of x is approaching positive infinity. It's going up on the left side. X approaching positive infinity. On the right-hand side, y is also going up. So that's positive infinity. So we come to this one and we look for the largest exponent, which is x to the third. It's a positive and it's an odd degree. So positive odd, that was down and then up. So if x approaching negative infinity on the left side, f of x is also approaching negative infinity. And on the right side, as x approaches positive infinity, f of x is approaching positive infinity. So we've talked about our degrees and our end behaviors.